If the sides A, B, and C of a triangle satisfy a squared plus b squared equals c squared, then the triangle is a right triangle. That should look familiar to you. We know that Pythagorean's theorem is talking about a right triangle, a squared plus b squared equals c squared. Number 3, we're trying to verify that. So it says, are the points R, S, and T the vertices of a right triangle? So they graphed it, and you look at it, and it looks like, well, maybe it could be a right triangle. But in math, you're not really allowed to just kind of assume. You can't really make assumptions. We like to prove things, okay? Is that really a right triangle? Maybe they just drew it not to scale. Maybe it is, maybe it isn't. I can't really tell from that picture, okay? Hard to tell. So what we can do is try to verify the Pythagorean theorem, okay? So we're looking at a squared plus b squared equals c squared. And I want to put a question mark at the end of that. Okay. We're actually going to test it out on this triangle. Let's see if that's really true. Okay. So check it out. I'm going to use the distance formula, but I'm also going to use my shortcut. Okay. Because I don't have a whole lot of room and it's kind of a lot of work. I want to use the shortcut. So let's look at the distance between these 2 points right here. Okay, look at the x numbers. -4 and 5. -4 and 5. What's the distance between those two x numbers? 9. Very good. So I'm going to have 9 squared plus. And then look at the y numbers, 3 and 1. What's the distance between those y numbers? 2. So I'm going to have the square root of 9 squared plus 2 squared. Yeah.
So why would the distance be 2 for 3 and 1?
Well, here, check it out. Okay, think about a number line. Here's 0. And if I go 1, 2, 3, there's -4.
Oh, it's because they're both positive.
Exactly.
Oh, okay.
So the distance between -4 and 5 is 9. Mm-hmm. I mean, think about what the formula says. The formula says you take one minus the other, and when you subtract a negative, you're going to be adding that 4, right? So that's a distance of 9, but the other one is just a distance between 1 and 3, and that's only a distance of 2.
Oh, okay, I get it.
Okay, great. No, good question. Okay, so I'm looking at what? Simplify that. Square root of 81 plus 4 is the square root of 85. Okay, square root of 85. So you have to do that for the other two sides as well. So let's look at this one. Okay. Look at the x numbers only. What's the distance between the -4 and the 0? 4. Look at the y numbers, 3 and -2. What's the distance between those two numbers? 5. So we'd have the square root of 4 squared plus 5 squared. That's the distance formula. I just skipped that first step. And if you're struggling with where I'm getting those numbers, then just use the formula and go back and do that first step, okay? Square root of x2 minus x1 squared plus y2 minus y1 squared. You can do that. Cleaning this up, I've got square root of 16 plus 25 is the square root of 41. And then we're going to do the same thing for this side right here. Okay. So again, look at the distance. This is the distance formula. So it makes sense to talk about the distance between the x's and the distance between the y's. What's the distance between the x numbers? 0 and 5. 5. So we're going to have 5 squared plus. And what's the distance between the y numbers 1 and -2? 3. So we're going to have square root of 5 squared plus 3 squared. Or square root of 25 plus 9 is square root of 34. Okay. Now that's all well and good. Okay. But remember what we're trying to do. We're trying to figure out if that's a right triangle, right? So we're trying to figure out if a squared plus b squared equals c squared. Okay. Now think about a triangle. A hypotenuse is the longest side, right? So C is the longest side, yes? So look at those three numbers there. Which one of those three numbers is going to have to be the C number? 85. The square root of 85, right? Okay, the square root of 85 is going to have to go over here if this is even going to possibly work. Okay, the other two are kind of interchangeable. It doesn't really matter, but square root of 34 squared plus square root of 41 squared equals square root of 85. And I'm going to leave that question mark, okay, because that's the question that I'm trying to answer. Is that true? Because if it is, then I know the right triangle. I know this is the right triangle. If it's not true, then I know it's not a right triangle. So do you remember what happens when you square root a square? Or you square a square root? Square root, it cancels out, right? So square root of 34 squared is just 34. And square root of 41 squared is just 41. And square root of 85 squared is just 85. Question mark. Your question is that true? Is it true that 34 plus 41 equals 85? That's not true because this is 75. 75 does not equal 85. So my conclusion is R, S, and T do not form a right triangle. Okay. Questions on that? Next problem is pretty much the same thing. Very similar concept. 3 points are collinear if the sum of the distance between two pairs of the points is equal to the distance between the remaining pair of points. I know that's hard to read. Read it again if you want to. But you should remember this concept from geometry. Basically, it's saying this plus this, part plus part equals total. That's how I taught it in geometry. But segment PQ plus segment QR is going to equal the total segment PR. And that should make perfect sense, right? Okay, that should make perfect sense. But in this problem, we're asking if that is true. Okay? We're asking a question. Is it true that this plus this equals this? Okay? So I guess I should move that down here maybe. I don't know. Can I grab it? There we go. That's a little too big. Okay. Question mark. So let's look at the distance from P to Q. Okay. Distance. Let's do the shortcut. I don't want to do, bless you, I don't want to do the whole formula. Okay. I'm going to do the shortcut. So PQ. What's the distance between the x's? 2. So 2 squared plus. And the distance between the y's? Also 2. So you're going to have square root of 4 plus 4 is the square root of 8. Okay? Correct? Now QR. QR. What's the distance between the x's? 8. And what's the distance between the y's? Also 8. So you have square root of 8 squared plus 8 squared. That's square root of 64 plus 64. That's the square root of 128. Now we look at PR. What's the distance between the x numbers? How much? Nope. Try again. Between negative 2 and positive 8, it's the distance of 10. Yeah, it's tricky. There's a lot of numbers going on, and I've got a lot of arrows going everywhere. What about the distance between 5 and negative 5? Also 10. So that's going to be the square root of 100 plus 100, which is the square root of 200. Okay? Now remember, we're asking ourselves a question, okay? Is the red plus the green equal to the black? Question mark. Now, everybody misses this one, okay? For some reason, everybody just looks at the numbers and forgets about the square root symbol, and they say 8 plus 128 does not equal 200, so no, okay? But you can't just ignore the square roots. Square root of 8 is not the same thing as 8, okay? You can't just ignore the square roots, all right? So, if I did the square root of 8 and the square root of 128 and the square root of, 200? Okay, check it out. You got 2.8 something plus 11.3 something equals 14.1 something. That looks like that could be right? I bet that is right. I think this one's going to be yes, okay? But in this chapter, we're going to need to practice with simplifying radicals. So let's go ahead and simplify the radicals just to practice, okay? So 8 can be broken down into a 4 and a 2. So 8 breaks down into 2 radical 2. Okay. 128. It's kind of a hard one because it's a weird number, but I know it can divide by 64. 64 and 2, so square root of 64 is 8. You've got 8 radical 2. Okay. And 200, I could split into 100 times 2. Square root of 100 is 10. So look at my question again. 2 square root of 2 plus 8 square root of 2 equals 10 square root of 2, question mark. Is that true? Yeah, that's definitely true. Okay. That's definitely true. So remember what we were trying to show. Are the points P, Q, and R collinear? So yes, we can say P, Q, R are collinear. Do you know what that means? What does that mean? Collinear, what does that mean? Are these 3 points collinear? No, because they don't do what? Not on the same line. So collinear means they lie on the same line. P, Q, and R lie on the same line.